Sir.
Good evening, beta. So, in the last class, we were discussing various aspects of the rotational motion. Now, try to understand the rotational kinetic energy. What is the meaning of rotational kinetic energy? So, here, if you are having an object like this, you are having an object like this, and it is rotating. This object is rotating about this axis. This is the axis about which this object can rotate. This is not leaving its place, but it can rotate only about this axis. Okay? So now, what will be the kinetic energy here? So because this all the particles of this object, they are moving. When it is rotating about this axis, automatically all the particles, they are going to move. They are going to displaced from its position. They are changing their position with respect to this. So it is rotating like this. Okay? It is rotating like this. So due to the motion of these particles, basically there will be a kinetic energy. If overall you look that, then translational motion is not taking place. So translational kinetic energy is not there. But due to the rotation of this object about this axis, it is going to have kinetic energy, and that kinetic energy is known as rotational kinetic energy. Rotational kinetic energy, I am talking about rotational kinetic energy. ठीक है. So rotational kinetic energy is the kinetic energy due to the rotational motion. Here we assume that there is no translational motion, so we can easily find out the expression of rotational kinetic energy here. Now I assume a particle. ठीक है, this is a particle of this object. You can choose any arbitrary particle. Suppose its mass is m, and its perpendicular distance from this axis is suppose r, or you can say it as mi, and this distance is ri. ठीक है, and it is rotating about this axis. This object is rotating about this axis by an angular velocity omega. So because this object is rotating about this axis, so all the particles of this object during this rotational motion, they will have same angular velocity. ठीक है ना? Because time period for all the particles, if you look at the time period of all the particles in completing one cycle, that will be equal. ठीक है? Why angular velocity will be equal? Omega will be 2 pi by t, and t is the time period, time taken by a particle in completing one rotation. And because this is a rigid body here, so all particles, they are at a fixed distance. So when this rigid body is rotating about this axis, then all the particles will take equal time in completing one cycle. So t will be same for all the particles. So angular velocity of all the particles of this object which is undergoing rotational motion will be same. So one thing is important here in rotational motion. In rotational motion of a rigid body, in rotational motion of a rigid body about an axis, about an axis, all the particles, all the particles, particles of rigid body have same angular velocity, have same angular velocity omega, angular velocity omega. ठीक है, omega. So if you consider the rotation of this particle about this axis, what will be that for this single particle? For this single particle, this will be mi. कितना होगा बेटा? Can anyone tell me? This will be half of, you can say simply mi, and this will be vi square. This will be the kinetic energy of this particle. So kinetic energy of this particle will be ki. That is the formula. But in rotational motion, if this distance of the particle from the axis of rotation is Ri, and this omega is the angular velocity, then you know that Vi, that will be equal to Ri omega. V equal to R omega. You are aware that this velocity V will be R times the angular velocity. This linear velocity will be equal to R into omega. You are aware. So substitute here. That will be 1 by 2 Mi. This will be Ri, and this is omega and square of this. So this is going to be 1 by 2. I write it Mi Ri square, and this will be omega square. Omega square. So this is the kinetic energy of this particle, rotational kinetic energy, because it is rotating about this axis. Now, what will be the total rotational kinetic energy of this body? Total rotational kinetic energy of the body K will be, it will be equal to, because this is a scalar quantity, so it will be equal to the sum of the rotational kinetic energy of all the particles. Okay? So how much will be the total rotational kinetic energy of the rigid body? Kr, you can write, this will be sigma of Ki, and it will be 1 by 2. I'm taking out. Sigma is going to act over I, so I will write it as sigma Mi. This is Ri square, and here this will be omega square. Omega is same for all the particles, so it will be same. I'm taking it out. And what is this quantity called that is in the bracket? What is this quantity? Beta, this is moment of inertia of this rigid body. So what is this? This is 1 by 2. 1 by 2 I. I is the moment of inertia, and this is omega square. So rotational kinetic energy of this rigid body, rigid body, this will be 1 by 2 I omega square. So if a body is undergoing only rotational motion, there is no translational motion, then its kinetic energy will be purely rotational, and it is known as rotational kinetic energy. So here we are choosing the case where there is no translational motion. We don't want a confusion with that. So we are not considering any translational motion, only rotational motion is there. So whatever kinetic energy will be there, that will be due to rotation. So due to rotation, particle of this body, they are moving. So automatically they are going to have kinetic energy, and that kinetic energy is equal to 1 by 2 I omega square. You call it as rotational kinetic energy. So this is the formula for rotational kinetic energy. This is the first thing. Is it clear up to this point, beta? Hello.
Yes, sir.
Very good. Next thing. Now you can consider different type of motions. Okay. Now we will further try to understand this is rotational kinetic energy. Here only rotation I am considering. Now consider this aspect. Suppose this is a sphere, or you can say this is a cylinder, or this is a disk. It may be like this. Suppose this is a sphere for simplicity, and this surface is frictionless. Okay, try to understand there is no friction. So friction is zero. Friction here, friction is zero. Zero. So if this object is going to move forward, this sphere is going to move forward, try to understand it will slip only. What you call this motion, this object, it is not going to rotate. For rotation, you need a friction force. Try to understand. If you want to rotate it, then you need a friction force so that a torque will be there. So if suppose friction force is acting like this, then this friction force, it can create a torque, and due to that torque, this object can rotate. But here I'm saying there is no friction. So there is only one thing: if this object is moving forward, with a velocity v naught, v naught. Then try to understand every particle of this object. You can choose any of the particle. It is moving with a velocity v naught. If you consider a particle here, it is moving with a velocity v naught. This is the center of mass, so it is center of mass velocity is vcm here. This v naught will be equal to vcm, center of mass velocity. You can choose any of the point. This is also moving with v naught. This is also moving with v naught. So each and every particle you choose here, they are going to move with the same velocity v naught. Okay, so this type of motion, what do you call it? You are going to say that this is slipping. What do you call it? This is slipping. This is just 1 second. This is slipping. Slipping. So only try to understand here, there is no rotational motion here. Only translational motion is taking place. Only translational motion is there. Only translational motion is there. Okay? If only translational motion is there, then what will be the kinetic energy? There will be only translational kinetic energy here. ठीक है, translational kinetic energy. So what will be the translational kinetic energy? Here you can assume that total mass of this object is focused at the center of mass, and center of mass is moving with a velocity v naught in the forward direction. So what will be the kinetic energy? That will be 1 by 2m, and you write it as vcm square, and vcm is v naught. So this will be 1 by 2 m v naught square. ठीक है? So here, basically translational motion can be represented by the center of mass. You will say all the mass of this object is focused at center of mass as a point mass, and that point mass is moving with the velocity of center of mass VCM. So that will be this one. So 1 by 2 mv naught square is there. ठीक है? So this type of motion will be there. So next, this is one type of motion where no rotational motion is there. Here, no rotational motion is there. No rotational motion. Okay. Next, or you can consider it as a disk. This is your choice. Suppose you are choosing it as a disk, and I'm assuming this disk is now here. Consider this is an axis. Now it is not moving forward. I'm saying now this disk is not moving forward, and it is undergoing rotation only. So this is a fixed here. So here this is a fixed stand on which this disk is rotating. Okay, so this disk is rotating like this. No translational motion is there. There is no rotation. There is no translational motion. So what you call it? You call it as spinning. What you call this motion? You call it as spinning. Spinning, you can say. So this type of motion will be there. And what will be the kinetic energy? What type of motion is there here? Only rotational motion. So what it will have? It will have only rotational motion. Only rotational motion will be there. So there will be only rotational motion. So what will be the kinetic energy here? That will be rotational kinetic energy, and that will be how much? 1 by 2 I omega square. We have just find out. So this will be the rotational kinetic energy. So if an object is undergoing spinning type of motion, here only rotational motion is there, then this will be the kinetic energy. Here no translational motion is there. No translational motion. No translational motion. Try to understand. No translational motion is there. Next, suppose if you combine these two motions together, means means slipping is taking place as well as rotation. ठीक है, spinning is also taking place. Spinning and this translational motion, spinning and slipping, both are taking place. If you combine these two motions, try to understand if we combine these two motions. ठीक है, if we combine these two motions, so when this is going to happen, when both the motions will be combined. ठीक है, if we combine now combine this pure slipping plus spinning together. Spinning together. Then what you are going to get? If you are combining these two together, then you are going to call it as rotational motion. What you call it as? This is rotational motion. ठीक है? Generally we study this in rotational. Rotational means here, ठीक है, rotational plus you can say translational. You can say in this way, translational motion. Translational motion. So you call it as rotational plus translational motion combined together. So both are taking place. So next question is, ठीक है, it's okay, slipping is taking place when there is no friction. But try to understand this rotation can take place before moving ahead. Try to understand when the rotation is going to take place if this is the surface. This object is moving forward with a velocity v naught. Try to understand. So pure, if there is no friction, assume there is no friction, then this particle, lowest particle that is in contact in the surface, that is also moving in the forward direction. ठीक है? If there is no friction. ठीक है? Now try to understand. But if this surface is having friction, so here in this case, there is no torque. If you look here, when friction is zero, there is no torque that can rotate this object. And for rotation, you know that torque is needed. If you want rotation, you need some type of torque. So when this torque can come into the picture, when this rotation can take place along with this translational, which is known as slipping here, when this is going to take place, try to understand if this surface is having some friction. If friction, this is a friction is not zero. If you say friction is not zero, ठीक है, you say friction is not zero, means this surface is frictional. There is some friction between them. Then what will happen? This particle is going to slip it is going to move in the forward direction. So there is a relative motion between the lowest point of this object and this surface. So automatically a friction force is going to act in this direction. ठीक है, this is a friction force. This is a friction force. So this friction force, ठीक है ना, it is going to create a torque about this point. So if I consider this point as C, then draw a perpendicular here. ठीक है, so this is R vector. I This is R vector here. Try to understand. And what is torque? Torque is R cross F. So torque that this friction force is going to create or produce about this point C, that will be R cross F. So this will be R cross F. So what will the direction of that torque? That will be from R. You have to make a curl from R to F in this way. So it means there is a torque that is acting and that is trying to rotate this body. So basically, if you need rotational motion here on the surface, what is needed? Frictional force is needed. Why frictional force? Without frictional force, this type of rotational motion is not possible. If someone asks you why, Because in the absence of the frictional force, there will be no torque. And when there will be no torque here, then it is not going to rotate. For the rotation, torque is needed, and that torque is provided by the frictional force. So only in the presence of frictional force, this object is going to rotate about this point. So torque will be here. You can write torque. Torque is R cross F. And here that force is friction force. So without friction force, there will be no torque, there will be no rotational motion here. It is like this. So in this direction, torque is, so torque, what will the direction of the torque? It is rotating inward the board. Okay, it will be inward the board. Torque is going to act inward the board. So frictional surface is needed. So there should be some frictional surface. There should be some friction between the object, lowest point of the object and the surface. Friction should be present for the rotational motion. So you should understand that friction is needed. Friction is needed here for the rotation. For the rotation. So here, this type of friction is needed. Is it clear? So what you are saying here, if you combine these together, if you are combining these two together, then you are going to have this type of motion. So this is a frictional surface here. This is a frictional surface, rough surface. This center of mass, it is moving with a velocity v naught. This is the velocity, or this is the speed or velocity of the center of mass, and it is rotating with omega. So this type of motion will be there. If you combine these two, then this type of motion will come into the picture. But if you need this type of motion where both translational motion and rotational motion is present, what is needed? Friction is needed. So friction is needed for this type of motion. Friction is needed for this type of motion here. So what will be here? Both rotational motion and translational motion will be there. So what will be the total kinetic energy? So what will be the total kinetic energy? Total kinetic energy will be equal to translational kinetic energy plus rotational kinetic energy, kT plus kr. And how much it will be? kT will be 1 by 2m. This is Vc square, velocity of the center of mass, plus 1 by 2 I omega square. I is the moment of inertia of this object about the axis of rotation. Okay, so this will be so this will be the total kinetic energy of the object if both rotational as well as translational motion is taking place. So when both rotational as well as translational motion is taking place, this will be the total kinetic energy. Okay, so this will be the sum of translational kinetic energy and rotational kinetic energy. Is it okay? Please note it down. Then I will move further. So what is needed here? Here, okay, what is needed? Frictional surface. So for this type of motion, what is needed? Frictional surface, because frictional surface will be responsible for a friction force that is going to create a torque, and that torque is going to rotate this object. So if there is no friction force, only slipping is going to take place. Slipping it will take place. It is like this. Next. Okay. So here, this is okay. Now, when you are combining rotational and translational motion, then there will be three resultant motion. Okay, three type of resultant motion may come into the picture. If you are combining translational motion, translational motion plus rotational motion, If you are combining these two, then three type of results may you get. If you are combining these two together, then there may be three consequences. ठीक है? This will be. ठीक है? First type of motion is known as slipping. तो slipping may take place. ठीक है? Second is skidding. ठीक है? Second is skidding may take place. Skidding may take place. And third, that is most important, and you are aware about this, that is known as rolling without slipping. Next is rolling without slipping. Rolling without slipping. So these three consequences may be there. ठीक है? These three consequences may be there. Is it okay? Now, before understanding these two, I am here when only slipping was taking place. Only in case of only slipping, suppose V naught is the velocity of the center of mass, then try to understand every particle, this topmost particle, it is also going to have the velocity V naught. And this lowermost particle, it is going to have velocity V naught. This is, you call it as slipping. You are combining it with spinning. So spinning, in case of spinning, try to understand, if you look at only spinning, then it is rotating like this with omega. Then highest point, how much velocity it will have in this direction, how much velocity it is topmost point, that will be r omega. How much it will be, this will be r omega. And this lowest point, if you are looking only this, then this will be r omega in this direction. ठीक है? This will be better. So here two type of motions were there. First was slipping, second was spinning. ठीक है ना? You call it as spinning. You are combining these two. So what will be the consequence here? Here, this is the object and it is having both. So try to understand what will be the velocity of topmost point. Here it is in this direction. This is in this. They are in the same direction. Look at the topmost point. ठीक है? Topmost point. Its velocity is in the horizontally toward the right, V naught. Similarly, horizontally toward the right, this is R omega naught. So topmost point, when you are combining this velocity will be how much? This will be uh, this will be V naught plus R omega. They are going to add each other. ठीक है ना? They will add with each other. So this will be V naught plus omega r. What is V naught? V naught is VC. If you want to write, it may be VC you can write. And what is going to have at the lowest point? Even I should write it as this. I should write it as V naught, VC. That will be better to remember. So I'm writing it as VC so that you can understand this is the velocity of the center of mass. And if you look at the lowest point here, lowest point will have a velocity component in the forward direction, that is VC, and in the backward direction, that is R omega. So this is the situation of the lowest point. I call this lowest point as P point. ठीक है? I call this point, lowest point is P point. Now corresponding to this situation, you can have three cases. One is known as slipping, another is known as skidding, third is known as rolling without slipping. So first is slipping. Slipping means, try to understand, slipping is going to take place when this object is going to slip. ठीक है ना? When this object is going to slip here in the backward direction. ठीक है ना? In the backward direction. So it will be like this. Try to understand some in rainy season how you slip. ठीक है? When you are going to slip, your legs, ठीक है, they may move in the backward direction. ठीक है? So that will be something like slipping. You are going to slip like this. So here, when it is going to happen, it is going to happen when R omega. Try to understand when this slipping is going to take place, when this R omega is greater than this VC. If R omega is greater than VC, then what will be the resultant here? You will have this type of motion. What you are going to have? Topmost point, it is having a velocity here VC plus R omega. R omega. And in this direction, resultant velocity will be here in this direction, and that will be R omega minus VC. This will be. So in this case, it is going to slip in the backward direction. It is going to slip in the backward direction. Okay? So this type of motion is possible. Means sometime what happens, rolling is taking place, it is rolling, but continuously it is slipping in the backward direction. So it's not pure rolling. Okay? It's moving forward due to rolling, but during its motion, it is a little bit slipped in the backward direction. So that is known as slipping. So this is the first case. Is it clear to you what I am saying, beta?
Yes, sir.
Now, second may be skidding. In case of skidding, basically this the resultant motion of the lowest point is in the forward direction. So when that is going to happen, if this VC is greater than omega, R omega. Second case is possible if velocity of the center of mass is greater than this R omega. Suppose this is the case. ठीक है? Many times your bikes and cars, you can skid them. ठीक है? That type of case is this. But remember this on in all the three cases, because rolling is taking place, then friction is must. Because without friction, no torque is there to rotate. Rotational motion is not possible. So here it is. This is frictional surface. Remember this here, here, here. I'm not drawing because I want to show these vectors, that's why. So in this case, what is going to happen here? Velocity of this point is V naught plus R omega. And here, there will be resultant velocity in the forward direction, and how much it will be? This will be VC minus R omega. VC minus R omega. So it is. ठीक है? VC minus R omega. Is it clear? Now, next third type of motion is rolling without slipping. Means it's not going to slip in the forward or backward. It is not going to skid. Here in this case, there should not be skidding. There should not be slipping. When it is going to happen, here only pure rolling, whatever motion particle is moving, this not particle, this object is moving, this rigid body is moving, that is only due to rolling. So in the third case, when this rolling without slipping will take place, that will be the case when these two velocities Vc is equal to R omega. So suppose here in this case is going to happen when Vc equal to R omega. Then try to understand here, this particle P, ठीक है, it will be at rest with respect to ground, because these two velocities, they are going to cancel each other. So whatever particle will be there in contact with the earth or with the surface, there will be no relative motion between this point P and the surface. Means translational motion of this particle is not going to take place here. ठीक है, it's not translational motion of this P point. It is not going to be here or it is not going to be here. Translational motion of this P is not there. ठीक है, here slipping or skidding is not taking place. After some time, this point, it will be here. That will be due to rotation, but not due to translation. After some point, this P point, this point will be here, and a new point will be in contact with the Earth because it is rotating like this. But try to understand translational motion of this P with respect to ground is not taking place because this Vc and R omega. So you can say relative motion between point P and the surface is zero. Translational motion, relative translational motion is zero. Rotation is going to take place after this point. If you place a red point here, then red point will be here, but then there will be a new point that will be at rest with respect to the ground. After that, due to rotation, these points are moving like this, but translational motion of this particle is not taking place. Pure rotation is there. So here, this highest point, what will be its velocity? Its velocity will be Vc plus R omega. And you know that R omega is Vc, so this will be 2 times Vc. Highest point speed or velocity will be 2 Vc. Try to understand for the center of mass, what will be the velocity? This will be Vc. And at the lowest point, velocity, it will be 0. If you are looking at translational velocity of this is 2 Vc. Translational velocity of the center of mass is Vc. But at the lowest point, its translational velocity will be 0. No translational velocity. So this type of motion where the lowest point P and the surface, they don't have any relative motion, relative translational motion, then that motion is known as rolling without slipping. Or you also call it as pure rotational motion about this point P. This will be a pure rotational motion about this point P. If you look at point P, okay, then you will find out this is purely rotational motion. ठीक है, because there is no translational motion if you look at P. From the point of P, from the point of view of P, there is no translational motion, only pure rolling. So that's why this case is also known as pure rolling. ठीक है, you can write it as pure rolling. Pure rolling about point P. Above point P. What is P? P is the point that is in contact with the surface. That is in contact with the surface. Is it clear? Hello.
Yes, sir.
Good. Now, so what I'm saying here, this is rolling without slipping. This is rolling without slipping. Now, it is moving with a velocity Vc. Vc. Okay. This point is P. P. So you can consider what will be the kinetic energy in this case. So kinetic energy in this case, this will be equal to, this will be translational kinetic energy plus rotational kinetic energy. When you are writing like this, then you are considering the rotation of this object about point C. ठीक है, so here you are considering the rotation about C. ठीक है, here, so your center of mass is moving forward, so this will be 1 by 2 m vc square. 1 by 2 or I should write it as capital M. 1 by 2 capital M vc square plus 1 by 2 I about which point? About point C. So this is about center of mass IC. 1 by 2 IC, and this will be omega square. Omega square. This is one way to find out. But if you look at other way here, because this is rolling without slipping, so this will be Vc equal to R omega. ठीक है, Vc equal to R omega. So try to understand. I can write it as 1 by 2 m, ठीक है, R square, and this will be omega square, plus 1 by 2 IC, and this will be omega square. If you take this 1 by 2 common, and this is first I'm writing IC, I'm writing IC first, plus here this MR square second, and this omega square is common. What is this telling you? Try to understand what is IC. IC is the moment of inertia of this rigid body about this axis that is passing through C. What is R? R is the perpendicular distance. R is the distance between this C and P point. This is R. So from the parallel axis theorem, ठीक है, try to understand about this point C. Moment of inertia. This axis is passing through the center of mass, and what is the moment of inertia about the axis that is passing through the center of mass? We are writing it as this IC, and then you are adding it. You are adding a term mr square with it. M is the total mass, and R is this distance from C to P. ठीक है, this is C to P. I can this point is P, CP, this is R. So what it will be? This will be equal to moment of inertia of this rigid body about an axis passing through this P and perpendicular to this axis. Earlier this was the axis. Now this IP is the moment of inertia about the axis that is perpendicular to the board but passing through this point P. Passing through the point P. So this will be IP. So what you write here, kinetic energy is equal to 1 by 2 IP. IP is the moment of inertia of this rigid body about an axis passing through point P and perpendicular to the board. So what is this formula? This is the formula of pure rotational kinetic energy. So basically this type of rolling without slipping motion, this can be considered as the pure rotational motion about the axis that is passing through this point P. So that's why this is pure rotational motion. You are saying pure rotational motion about an axis passing through point P. This will be. So that's why you can not only use this formula is okay, there is no problem with this. But you can also use this one. This will be. So sometimes you are going to find out that they are using the word pure rolling. ठीक है, that's the reason why they are using the word pure rolling. Is it clear, beta?
Yes, sir.
Good. Now, motion of a body rolling on an inclined plane. Next is, please note it down first. Next is motion of a body rolling over a inclined surface. Motion of a body rolling over an inclined surface. An inclined surface. One more thing, can you tell me in this case where this rolling without slipping motion is taking place, ठीक है, friction is present. Without friction, rotation is not going to take place. So can you tell me, due to the frictional force that is acting here in rolling without slipping motion, that is going to dissipate some energy, system is going to lose some energy or not due to that friction force or not? System will lose some energy here. So what is my question? ठीक है, my question is here, ठीक है, in this case, ठीक है, energy will be lost. Energy will be lost due to friction, due to friction, ठीक है, friction during during rolling without slipping or not. Uh, uh, so my question is, will energy, I just modify this. My question is, will energy be lost? And so this is my question like this. Okay. So you have to tell me. So in general, what happens whenever friction is present, work has to be done against the friction force. To overcome friction force, some work has to be done and energy is lost. System is going to lose energy. But here, what is happening? Try to understand. In this direction, rolling is taking place, and this is the surface. You are going to tell me. So in which direction this friction is going to act? Try to understand this friction is acting. Suppose in this direction, this is friction force. This is point P, and velocity of the point P is 0. So Vp is 0. With respect to ground, this point P, there is no relative motion between this P and this ground surface. So this is 0. So this point is at rest. There is no displacement. Try to understand. So here, displacement is 0. ठीक है, there is this P point, there is no relative motion between this P and this ground surface. ठीक है, so due to this force, friction force is acting, but there is no relative motion. Friction force is existing, but no relative motion is taking place. No displacement is there. So work done by the friction force is 0 here. Try to understand here. Work done by the friction force or against the friction force, by the friction force is 0 because there is no relative motion. Relative motion between point P and the surface. So here energy will not be lost. System is not going to lose the energy. Friction force is existing, but system is not going to lose the energy. So this property I'm going to use in the next one. Okay, so in the next, I'm going to consider this. So what you are having here, there is an inclined surface. So here I am having some, so this height is h. I say length of the slope is s, and an object, it may be cylinder, it may be sphere, or it may be disk. Okay, so it is here. Okay, it is going to slip. Sorry, it is going to undergo rolling without slipping. So it moves like this. It is going to move like this. Now, what type of motion is there? Rolling. Motion of a body rolling without slipping. So what is this actually? Rolling without slipping. Without slipping. Okay? So V will be equal to R omega. This condition is going to be satisfied. Now here it starts moving in the down. So it's moving in this direction. Initial velocity will be 0. Okay, initial velocity will be 0 when it is reaching here. When it is reaching here, try to understand. At the lowest point, here, it has traveled a distance s, and it is going to have a velocity v. It will have a velocity v. So when it will reach here at this point, its velocity will be v. Here, u is 0. U is 0. Find this v. What will be the velocity of this cylinder or sphere or the disk when it is going to reach here? Find v. So what do you have to find out? Find the velocity v at the lowest point of the slope. Lowest point of the slope. You have to find out. Find the velocity v at the lowest point of the slope. You have to find out this. So try to understand here. This question is very easy to solve. Conservation of energy will be there. I have told you that, okay, if this is surface is frictional, but this friction force is not going to do any work. You don't have to do any work against the friction force, in other words. So energy is not going to lose. Energy is not going to lose here. Energy will be conserved. So what you have to do, you have to apply conservation of energy. What is the height here? Here initial velocity is 0. Here initial velocity is 0, but its height is h. So it is having potential energy mgh. It will have a potential energy capital M, G, and H. This will be mgh. It will be equal to, at this point, try to understand, it will have rotational kinetic energy. It will have, suppose at this point, its rotational velocity is omega, angular velocity is omega, and velocity is v. So I will write 1 by 2 mv square. plus, try to understand here I am assuming potential energy is 0 at the lowest point. ठीक है, or you can say when it is on the ground itself. Potential energy will be 0 only, kinetic energy will be there. Kinetic energy will be of two type. One will be translational kinetic energy and second will be rotational kinetic energy. I omega square. ठीक है, so I take this 1 by 2 m v square common. So here this will be 1 plus, it will be I omega square divided by mv square. And on this side you are going to have mgh. So m will cancel out and this v square. So I can write it as 2gh. 2gh, I bring this 2 here and this will be v square and this will be 1 plus, this will be I, v equal to r omega. Try to understand this v equal to r omega. If I substituted v equal to r omega, omega will cancel out and this will be I upon mr square. This will be. So what is the velocity? Velocity at the lowest point, this will be कितना होगा बेटा? This will be root 2gh. Root 2gh will be there divided by, this will be square root of 1 plus I upon mr square. I upon mr square. This will be the velocity at the lowest point. ठीक है? What will be the acceleration here? ठीक है? What will be the acceleration here? ठीक है? During this motion, what will be the acceleration? ठीक है? Acceleration you have to find out. So here velocity was 0, here velocity is v. ठीक है? So if you look at, if you, this is u, this is v, then you can say this v square is equal to u square plus. So can you tell me what forces are acting here? ठीक है? What forces are acting here? For the translational motion, only one type of force is there, that is gravitational force. So whatever acceleration will be there, that will be constant. So that's why constant acceleration is there. So uniform accelerated motion is there. So I'm using the formula v square is equal to u square plus 2as. 2as. U is 0. U is 0 here. And what is v square? V square is 2gh. I write here 2gh divided by, this is 1 plus I upon mr square. On this side, this will be 2 here. I'm interested in A. And what will be S? If you say that this angle is theta. Theta. What is the correlation between H and S? Sine theta. You can observe sine theta is equal to H upon S. ठीक है, H upon S. So this H will be, or you can say this S will be how much? This will be H upon sine theta. H upon sine theta. So here I can write H upon sine theta. So this 2 is going to cancel out. H is going to cancel out. So this will be G sine theta. What it will be? So what will be the acceleration from here? Acceleration A, that will be equal to, this is G sine theta. G sine theta upon 1 plus I upon mr square. This will be the acceleration. This is the velocity. This is the acceleration. If you want to find out time, if you want to find the time, time will be how much distance is traveled, that is S. So S will be ut
Sir, 1 minute,
plus
sir.
1 by 2
Hello, sir.
at square.
Hello, sir.
So this u is 0 here.
Sir.
So time t will be equal to 2s upon a, and this will be square root of this.
Hello, sir.
ठीक है? Hello?
Sir,
Yes बेटा?
previous slide, please.
बेटा मुझे आपकी आवाज नहीं आ रही.
Previous slide, please, sir.
Okay, just please. So what it will be? This will be 2s here and a. So if you look at, this will be 2s and a g sine theta, g sine theta, and here it will be 1 plus I upon mr square. ठीक है? And you have observed that h upon s was sine theta. H upon s is sine theta. So in place of s, I can write h upon sine theta. ठीक है? So I write here, then it will be sine square theta. So what will be the time? That will be, this will become, here it will be h upon sine square theta. So 1 upon sine theta will be out, sine theta, and this will be square root of 2h upon g, and that is going to 1 plus I upon mr square. This will be the time taken by the sphere, by the cylinder, ठीक है, by the disk to reach at the lowest point. ठीक है, this is the time taken. So one more part is there regarding this type of motion. In the next class, first I will compare the motion of cylinder, disk, sphere, ठीक है, that type of motion for this case, and then I will further discuss. In the next class, theoretical part and some numericals will be completed in next 2 classes, I think. 2 or 3 classes, I will be able to complete this part. And after that, I will, after completing this chapter, I will start fluids. ठीक है? Fluids. Okay, so now you can save all these slides. This is first one. This is the first slide. Second one. Third one. Fourth. Fifth. Fifth. Sixth. Seven. And this is 8. This is 8th chapter. So these are all the slides. So in the next class, I will discuss complete theoretical aspects of this, and then 2 classes, I think, for the rotational motion numericals. I will discuss numericals after that related to rotational motion. Okay, beta. Thank you very much. Good night.
Thank you, sir.
Welcome, beta.